them to achieve this. So for the fishery service, we are looking at potential fish zone maps overlaid with fish vessel traffic information, and this is generated for the exclusive economic zone for each of these countries that we work with. So we are seeing samples of these potential fishing zone maps overlaid with vessel trajectories and vessel monitoring reports, which are sent to the monitoring, control, and surveillance units of all these countries. These are samples of the oceanographic data sets, which are also data that has been reprocessed, obtained from Mercator Ocean International as well. For the coastal services, we are looking mainly at land cover maps, generation of mangrove extents, and these are also generated into policy briefs for decision makers. In trying to expand the reach of some of these products, a mobile application has been developed to be able to get access to some of this information. So this would have information on the ocean state maps, which give information about the state of the ocean for fishermen before they go out to sea, which is provided in 3 main languages, in English, in French, and in Portuguese. This app is available on the Android Play Store and also on iOS. You can search it using GMES UG. We've also had several bulletins which we produce and circulate amongst these stakeholders. And some of these have been institutionalized amongst certain agencies, such as the Ghana Meteorological Agency in Ghana, to provide information on ocean states. We also do several capacity building activities, one of which is happening right now, and we intend to continue in this light for the next couple of years. We would also be assisting in providing postgraduate thesis completion grants. So please be on the lookout for that one as well, in case you might be interested. We also try to engage startups and private companies to bring out innovations into how we can continue to monitor the ocean environment. Most importantly is how we want to get women and the youth involved in some of these activities. So we'd encourage particularly the females to get involved in some of these training programs and take advantage of what we have to offer underneath this project. These are some of the dissemination channels that we usually go through. In case you have any extra information, please do well to consult any of these channels. I'd like to end the presentation here. Thank you. Based on where you're joining us from, I'd like to say thank you to you all. I'd like to move on now to my next presentation, and it's going to be on the EU and the Copernicus program and how they are supporting with the GMES and Africa initiative. Fabrice and Haley, are you there? Can you hear me?
Yeah.
Yep. Hi, Ignatius.
Okay. So I'd like to hand over the training officially to you now, and please you can take it away. A reminder to everyone who is joining us in, once the presentations are going on, this session is being recorded and it will be made available on the DLP platform. If you have any questions, please do not hesitate to put them in the Q&A session and we'll try to address them as much as we can. Thank you.
Thank you, Ignatius. Can you see my screen? It's okay? Okay, perfect.
Yes, we can.
So I will start to introduce the Copernicus program to you, and then with Hailey, we'll give you an overview of the different marine data portfolio available through EUMETSAT or the Copernicus Marine Service. So let's start. So first of all, my name is Fabrice Messal. I work at Mercator Ocean International as a user experience and capacity development manager. Mercator Ocean International is a non-profit company, the implementer of the Copernicus Marine Service. Hailey, I'll let you introduce yourself.
Thanks, Fabrice. Hi, everybody. I'm Hailey. First of all, must apologize. I have completely the wrong background, but I can't get the right one for today to upload on Teams. But I have got my GMES t-shirt on, so I'm hoping it'll let me join the training. Nice to meet you all. For those of you I haven't met before, I'm Hailey. I work at EUMETSAT, as Fabrice said. EUMETSAT is an international organization. We have 30 different member states. mostly from around Europe, but we do a lot of work, particularly collaborating with the African continent because of the satellites we operate. That's our main mission. We operate mostly weather satellites for Europe, but also a number of satellites under the Copernicus program, which you're going to hear more about in a second. So that's how come I'm here. I'm also very passionate about working with remote sensing data across the continent. I did my PhD in South Africa, and it's been my pleasure to work with some of the people behind the GMES UG project for some time. So I'm really excited to be here today and to interact with you all over the coming days. So thank you. Fabrice, back to you.
Okay, thank you, Hayley. Yes, we are very pleased to present this workshop, which we have prepared jointly with EUMETSAT and University of Ghana. And as the implementer of the European Marine Service, we are very much involved in the development of joint activities on marine data exploitation, like today when we are trying to do our best to support GMES and Africa consortia and their training efforts and the use of Copernicus data by user. So let's continue this presentation about the EU Copernicus program first, as an introduction. Let me know if you have access to the sound of these videos. It's okay? No? Okay.
We're seeing the video, but we're not getting the sound, though. I think is there sound to it?
Yeah. So let's just... okay. It should work now.
We live in a world characterized by overwhelming environmental challenges. We must try to tackle the effects of global warming, the problems created by both overpopulation and overconsumption, and the depletion of natural resources. How can we best manage our consumption and utilization of our Earth's natural resources and protect our environment? To answer this and other related questions, we constantly need to be aware of the state and health of our planet. The Copernicus program helps us to achieve this by observing our environment, collecting, storing and analyzing data, and providing products to enable effective decisions to be made. Brought together by different stakeholders in the European Union, Copernicus monitors our planet and its many ecosystems, while ensuring that its inhabitants are prepared for and protected against crises and natural or man-made disasters. Copernicus information services are based on data from a constellation of 6 families of satellites, known as the Sentinels, and dozens of third-party satellites known as contributing space missions. These measuring devices in orbit sometimes operate alone, and sometimes combined with sensors placed on the seas, land, or in the air. Copernicus then stores the data and helps to provide a large amount of reliable and up-to-date information on the status of our planet. This data can be used to create different kinds of products, such as statistics and topographic maps. The data is analyzed in a way that generates indicators useful for researchers and end users, providing information on past, present and future trends. Copernicus contributes not only to European scientific and technical excellence, but is part of a public service framework, allowing full, free and open access to all data collected. Anyone, scientists, policymakers, entrepreneurs, and ordinary citizens can use this data. Its missions also include essential interrelated themes, incorporating 6 sets of services: atmosphere monitoring, marine environment monitoring, land monitoring, climate change, emergency management, and security that translate into concrete and effective areas of application. With regards to the environment, Copernicus detects the content of aerosols that destroys the ozone layer, analyzing atmospheric composition and biodiversity. It is regularly evaluating the melting of the polar ice cap in the Arctic as a result of temperature increases due to global warming. It determines the quality of air and water that affects our health. It monitors ocean levels, coastal areas, and forests in order to limit the damage from the threat of earthquakes, floods, and fires to ensure our safety. In the energy sector, Copernicus promotes the use of hydraulic and wind power plants, promising clean, eco-friendly alternatives to fossil fuels. This will allow for renewable energy to account for up to 27% of our total energy consumption by 2030. Copernicus also supports the monitoring of the external borders of the European Union, using space data merged with other sources of information to increase situational awareness and improve assessment of risk at the external borders. Serving the marine world, Copernicus tracks marine pollution affecting aquatic ecosystems and the fishing industry. As part of a development cooperation policy, Copernicus warns of early signs of deforestation and desertification in order to avoid the problems of loss of biodiversity and food shortages. It oversees the irrigation of fields and monitors crops for better food management. It is also instrumental in tracing outbreaks of diseases, such as Ebola in West Africa. Further to these examples, Copernicus can serve the tourism industry, urban development, archaeology, oil and gas, and the insurance sector. It is an incredible tool, efficient, constantly evolving, open to all, and free of charge. And this will always be the case. It is a tool to create new applications, new opportunities, new markets, new jobs. Independent studies indicate that by 2030, nearly 48,000 jobs could be created by the application of Copernicus. And why not? Tens of thousands of users already make use of the data which is freely available. Knowing that each euro invested in satellite technology represents a high return on investment, the number of business opportunities is likely to increase in the coming years. New horizons are coming ever closer to us, here on Earth and in space.
So, okay, the video is very explicit. So I will do some recalls from the video, but what you need to remember is that Copernicus is a flagship program of the European Union to monitor the Earth, its environment and ecosystems, to prepare for crisis, security risks, and natural or man-made disasters. What you need to remember is that also it's made in the frame of a full and free and open data policy. So it means that all the variables accessible on the Copernicus, on the different Copernicus services are free and open. So you have just to register on some platform to have access to all this data. And as explained in the video, it's a tool for economic development. So it means that these core products are free. You are free to use it to produce added value products and make your own application, and then to sell other kind of services to end users. So it's very a powerful tool. So behind this program, you have two main parts. The infrastructure part with the space component and the in-situ component, and the services. And today with Hayley, we're going to dive into the two portfolios provided by Mercator Ocean for the Copernicus Marine Services and EUMETSAT for the Sentinel missions and other complementary missions. So as you saw in the videos, the usage of such portfolio of data is very wide. You can use it to protect the environment, to promote renewable energy, to monitor the environment. So it's very, very wide in terms of activities you can do with this kind of data. And you can touch every sector of human activities. So this is a service which is driven by the users. It means that we are very, very interested by to collect the feedback and the requirements from users in order to improve our services in terms of data sources, infrastructure with the space and in situ component, and also to improve the different level of information available from the different Copernicus services. This is very important in order to serve all the needs as much as possible. About the Copernicus space data component, so the space data are very useful as data itself, but also to validate all kind of products behind from the different thematic services. When we talk about the Copernicus space data, we talk about Sentinel missions. This is the main missions of this program with the different Sentinel. And as you can see with the different logos, which satellites is available. The product from each satellite are available on the different services, and the contributing missions, which are very complementary missions to serve all the data and product new kind of data. So the Copernicus in situ data, this is mainly observation data from ground, from sea, or airborne sensors. And the use of in situ data are like the Sentinel data to validate and calibrate other Copernicus products, and also reliable information services. So you can find in situ data in each thematic services, and there is an entity which is dedicated to manage all this infrastructure of in situ data, which is the European Environment Agency. And finally, all these data which are produced are available through different services. So you have the satellite data available on EUMETSAT portals and other kind of website, and all the data you can produce in Europe in terms of not only observations but model data, for example, you will see this later, are available through the different Copernicus services related to different themes, like the climate change, the marine monitoring, atmosphere monitoring, land monitoring, security, emergency management. It means that if you are looking for marine data, okay, you can go on the Copernicus Marine Service to find model data, in situ data, or satellite data, or you can go on the EUMETSAT portal to have access to Sentinel information, Sentinel data at different level of processing. You will see that with the different presentation. So to be completely transparent and to give you a clear overview of which data you can find between the EUMETSAT portfolio and the Copernicus Marine Service portfolio. On EUMETSAT, you will find Sentinel and contributing missions. So you will access images in near real-time plus archives. And on the Copernicus Marine Service portal, you will find in situ satellite and model products. Satellite products are different from EUMETSAT products regarding the different level of processing of data. From you will find what we call L1, L2 processing data, so with a lower level of processing data in the EUMETSAT portfolio and the L3 and L4 data processing data on the Copernicus Marine Service. And you will access also to archives, near real time, and forecast products thanks to the model. So this is an infographic with the different portals available on the galaxy of the Copernicus services. And to complete this big picture of our services and what we're going to talk about in this workshop today, there is also the WEkEO platform. The WEkEO platform is a data and information access service platform, which give you access to all the Copernicus service portfolio, the Sentinel mission portfolios, and access to computational resources. Also, this is a very plus of WEkEO. So computational resources to compute the data directly near the data. So you don't have to have a big computer or to work on the data. You directly can access to computational resources to make all the computation with this kind of data. So this is the big picture of what we're going to present to you today. So let's start now with the portfolio of EUMETSAT, introduced by Hayley.
Thanks very much, Fabrice. Can I ask you to move the slide on one for me? I think the controls are working from your side, correct?
Yes, no problem.
Lovely, thank you. Okay, hi again, everybody. So thank you, Fabrice, for that information and introduction to the Copernicus program. I'm going to talk a little bit more about EUMETSAT, what we do and our role in Copernicus, and give you a bit more detail about some of those products that Fabrice mentioned and some of the things that you heard about, levels, sentinels, all these different things. So to start with the big picture, you can see in the image in this slide currently all the different satellites that we are currently operating at EUMETSAT or that we will be operating in the near future. And you can see there's a lot of them. And as I mentioned before, a lot of them are related to our responsibilities in weather and climate monitoring. But a number of them are also geared towards measuring and monitoring the oceans, particularly under the Copernicus program. And you can see those in the bottom of the diagram. We have the Copernicus missions, but I can say already that some of this is out of date because we will actually be flying more missions than this in the coming years. I think every time I use this slide, I look at the diagram and go, oh, we've got another one coming soon. So actually, I need to add that. But let's talk about the ones we already have flying at the moment. So the two main missions that we fly for the oceans at EUMETSAT under the Copernicus program are Sentinel-3, which has been the first one started flying in 2016, and the Sentinel-6 missions, the first of which was launched in late 2021. From these satellites, we produce data at different what we call timeliness levels. As Fabrice mentioned, we produce the data in near real time. So the data comes from the satellites and we try and get it to users as quickly as possible. So this is particularly important for applications where you need data really quickly. And in this case, it's mostly within 3 hours that you'll get that data from the satellite down to your computer to work with. So it's already available. That's the NRT. We also do provide data in other timelinesses. You'll see STC and NTC as terms thrown around. These are short time critical and non-time critical. And these are data sets with a slightly longer processing time, but with increased accuracy that we can get from bringing in extra data to do the processing. We also have reprocessed data sets. So periodically we'll go back and look at the whole archive of this particular satellite mission and try and improve the processing to make it more consistent over time. We learn more about the instruments and how they work. So this is something that's quite important to do, particularly to feed down into the products that the Copernicus Marine Service produce. So most of the data that we're producing is what you would be calling level 1 or level 2. And at level 2, what you're getting is what we would know as geophysical products. So these are things that you might be familiar with if you're working in the marine domain, things like chlorophyll concentration, sea surface temperature, sea surface height, these kind of things. So we already are providing those measurements at level 2. So these are the two missions that EUMETSAT operates. Data, we'll talk more about those in a minute. And Sentinel-6 is primarily an altimetry mission. We'll also be flying the Sentinel-4 and 5 missions in the future. These will be more atmospheric composition orientated. And then beyond that, there's a whole bunch of other Sentinels that have recently been approved that are not on the diagram here. So SIMA, CO2M, and Crystal, you might hear about in the coming months to years. And those are ones that we'll be flying as well. And the core user of all this data, besides you all, is of course the Copernicus Marine Service, who Fabrice and Fifi work for. So a lot of our data gets used by them. Next slide, please, Fabrice. So let's look a bit more at Sentinel-3, colloquially known as the Blue Sentinel with its ocean mission. It provides 3 different types of data, as I mentioned before: ocean color, sea, and actually as well ice and land, surface temperature, but we're not so interested in the land at this point, and altimetry data. So you can see there in the slide the different types of parameters that you can get out from these 3 main instrument streams, including things that are related to the physics of the ocean, but also the biology and chemistry. We provide the level 1 and level 2 data, as well as some experimental processes that you can use to derive some different variables if there's things there that you're also needing. We mostly cover all the ocean processing here at EUMETSAT, but we also do some work on large inland water bodies, some stuff on sea ice and the leads into sea ice as well. That's included under our kind of marine portfolio. Land and land ice products from Sentinel-3 are, however, produced by our colleagues at the European Space Agency. So if you're looking for other products from Sentinel-3 for land, that's who you can talk to. Next slide, please, Fabrice. This is Sentinel-6. So this is another one of our marine missions. There's only one of these satellites flying at the moment. There will be 2. There's already 2 Sentinel-3s going. Sentinel-6 is primarily an altimetry-focused mission, and it builds on this strong heritage that EUMETSAT has, along with our colleagues at NASA, NOAA, and CNES, in operating these altimetry missions that measure sea surface height and sea level. This is something that's been going on for a long time now to monitor what's happening with our sea level with regards to climate change. So it's a really important kind of continuity mission for keeping that long time series growing, so we can understand these changes to our planet. However, Sentinel-6 does offer some new advantages over some of the other altimeters. It has a very frequent revisit compared to Sentinel-3, and it has higher resolution and uses a more modern technique known as interleaved SAR mode to allow it to be both kind of cutting edge in its technology, but also climate compatible with a long time series record. As I said, the main mission is altimetry, so it's important for us ocean-minded folks, but it also provides radio occultation data. If this is something you're interested in, you can have a look and check that out in more detail later. Next slide, please. Just a few words on data formats and availability. So this image shows you the different, what we call product dissemination units. So this is really, in practical terms, kind of the shape and size of the files that you'll get from data from Sentinel-3 and 6. Depending on which instrument you're looking at, you can see that they vary, and they also vary depending on the timeliness. This allows us to get the data out as quickly as possible, and also to keep it as accurate as possible for like sort of highest fidelity when you're looking at trying to get the closest point in time and space to measurements that you're making, for example. The coverage of the different data sets varies. Some of the data will be covered, you'll get daily images from your area if you're looking at the optical data from ultra-level STR, for example. Whereas with the altimetry, because it's these narrow little along track measurements, it takes a longer time for the satellite to come back and cover that exact spot again. The products in our data store and in our collections that you'll see later on WEkEO are generally collected by type. So you'll see them by level and then also by type of instrument, so by ocean color, SST, altimetry, and also by status. So we have our collections that are operational, where the data is churned out every single day. And then we have our reprocessed collections, which are our longer term archive collections that you can look back through time at the kind of cleanest, most appropriate processing we've got of the data. And these can all be filtered by these different parameters, so you can find exactly the data you need. Next slide, please, Fabrice. In terms of data access, we offer various different ways of accessing the data from EUMETSAT. We have a view service where you can just look at imagery. We also have a long-term archive where you can request data from our storage systems. More recently, we've released our data store. This is relatively new. This gives online access to all the data available from Sentinel-3 now, and as well soon from Sentinel-6, as well as all our other missions. This is replacing a service that some of you may have used. If you used our data before, you may have used CODA or the CODA rep services. This is the replacement for that. We also have what we call our push systems, where we send data out and you can receive it from a satellite dish. I know the University of Ghana has one of these systems, maybe some of your organisations do too. This is our EUMETSAT satellite systems. Similarly, there's also a terrestrial network that does something similar, which you can find out more information about if you would like. And the last thing I'll mention there is our data tailor service. This is something we're using more and more now to allow users to customize data before they download it, so they can do certain transformations without having to download the data. Soon we will have capability available in this for using Sentinel-3 and 6. It's not available yet, but it's ongoing work at the moment. We expect the first version in the next couple of months, so that's quite exciting. But important for you in the context of this training is that from our data store, our data for Sentinel-3 and soon Sentinel-6, it's not currently there, but it will be soon, feeds out into the WEkEO system. So you'll learn later on in this training course how you can access the data I've just been talking about from that system. Next slide, please, Fabrice. And so then just to give you a few sort of tips about how you can engage with us at EUMETSAT further beyond this training course. We have a lot of information out there that you can use to learn more about the satellites, about our data and the data access methods. We provide a lot of code-based tools, which you'll have much more experience with in the coming days this week to help you work with our data. We provide case studies showing how our data can be used. I'll show you some more of those in a follow-on presentation later this afternoon. And we also do more in terms of training. So beyond this course, we also have standalone training resources that you can use, and we have various different courses that you might want to consider attending in future around specific topics. So yeah, please do keep in touch with us. We offer lots of support for you as you go through your journey using satellite data, and we're always happy to hear from you. And if you have any problems with our data at all, you can also contact ops@eumetsat.in. That's our main help desk. So actually any contact at all really can go through there. Okay, I think that's all my slides, maybe. Let's see. Yes.
Thank you, Hayley. Okay, so I will continue with the Copernicus Marine Service portfolio. So, the Copernicus Marine Service is one of the 6 thematic services, so implemented by Mercator Ocean International. So it gives you access to different kind of data, in situ data, satellite data, and model data. Thanks to all this data, we can cover a wide temporal coverage with reanalysis over the 25 years in the past, real-time data and forecasts. And the data cover the European basins and also the global ocean. In terms of sources of data, so as I said before, we have satellite observation data. Comparing to the data provided by EUMETSAT, we provide also L3 and L4 data for the products available on the catalog. As a reminder, you can say, okay, L4 data are interpolated data on grid. And with L3 data, you can have a long track data, or for some of them, already graded products. And you have also in situ observation data from different networks and platforms around the world, with Argo floats, gliders, research vessels, ferry boxes, tide gauges. So you have information on the ocean with different kind of variables. Near the surface, with high resolution, spatial resolution, and you can have near real-time products and multi-year products. And then you have model data. So we have a numerical representation of the ocean in which we assimilate observations from a satellite and in situ in order to create analysis and forecasting systems in order to have information about the state of the ocean from the surface to the bottom. So this is 3D information about the ocean. And thanks to that, we can have forecast until 10 days. So it's very useful when you want to observe change in the ocean, because we have also multi-year products. And if you need information in the future in order to predict oil spill, for example, or to predict navigation routes, you can use forecasts. So each time we try to present all the parameters available on the Copernicus Marine Service with these different, the different colors of the ocean, with the blue ocean, with physical parameter of the ocean, with temperature, salinity, temperature at the surface of the ocean, but also in different depth, with salinity, the currents, the waves, the sea surface elevation, and the surface wind. We have the white ocean with information about the sea ice, can be sea ice concentration, sea ice thickness, and the green ocean with information on the primary production, the water quality with transparency and turbidity, the oxygen, information about biological levels with zooplankton, micronecton models, carbonate systems, and nutrients with information with on nitrate, phosphate, and other kind of nutrients. For example, what could be interesting for you? I took some example on the catalog of products on the global ocean. If we filter the data on the blue ocean, you will have 16 global products available. And for example, you can have the first one, which is a physics analysis and forecast updated daily products. This is our flagship product in the catalog, the most used by the users, with information on the temperatures, the salinity, the currents, sea surface height, and the model is updated hourly, daily, and monthly. The frequency of the products can be hourly, daily, and monthly. We have the same kind of model, but with what we call reanalysis. So we run this model, but with all the observation data we can assimilate to this model. And we try to have this view in the past, over the 25 years in the past with this model. So very useful if you want to study long time series, long time changes. We have the wave analysis and forecast. So this is the same principle than the physical model, but only for waves and the wave reanalysis. For the green ocean, the biogeochemical products, if you active the filters on the catalog of products, you will find 3 global products available with mainly the main product, which is the analysis and forecast model product. And for example, also the low and mid trophic level biomass product with information about the aphotic zone, micronecton, zooplankton. About the observations, you will have 11 global products available with a lot of in situ observation in real time accessible on the website since 1950. Also information with satellite information about the sea surface salinity, satellite information also on the wave. This is information about the Copernicus missions, Sentinel-6 and Sentinel-3, Sentinel-1 missions. And you have also information about the green ocean with 19 global products available with information on the chlorophyll, the different nutrients from in situ data, but also satellite data. Don't hesitate to have a look on the catalog on the website. So this is the website. This is the focal point of all the data. You can access to the ocean products catalog. You have also different information products like the indicators, what we call ocean monitoring indicators with essential variables, with some trends, some maps you can directly download. And we have different ocean visualization tools to give you access to this information and to start to play with the different products. So you have access to more than 300 scientifically qualified products. You have just to register. This is completely open and free, as I said before, following the European data policy. Today, we have more than 45,000 users all around the world. And as I said, as the Copernicus program, this is a user-driven service. So we try always to keep the contact with the users in order to improve our service, our catalog of products, and to give the best experience of user journey on the website and the service. When you have chosen the product, you have you can download the data, you can access the data, and to do that, we have different protocol of access. You can directly download the data, subset the data, or access to different WMS or OpenDAP, RDAP protocols to access the data. For each product, you will find an associated documentation with the product user manual and also quality information document, information about the products, okay, the geographical and temporal coverage, the variable inside the product. And you can also have information about the real-time notifications. If there is some problem, some improvement on the products, you will be informed as soon as possible. Sorry. As I said, we provide also ocean monitoring indicators. They are key variables to monitor the climate change through the ocean. So also, this is free downloadable data set covering the 25 years. And you have information about the sea ice extent, the sea level, ocean heat. This is some example of the different ocean monitoring indicators. This is very useful if you are working on environmental report or climate change report and you're looking for direct information, direct maps or trends. We try to provide the needed information and tools to users to understand our product and to use our product. So we have an e-learning material webpage, and we provide also training material and training workshops. We have Jupyter notebooks available, some scripts in Python, tutorial videos on our YouTube channel. And this is the upcoming events from the Copernicus Marine Service training team. So in May, we will have a marine data for Africa training workshop, so dedicated on the region of Africa. This training will cover all kinds of data available on the Copernicus Marine Service. So don't forget to note the date, and I continue to be present to this training workshop. We have a unique service desk. We try to, again, provide support with this user support to all kinds of users. So don't hesitate to contact them if you have any question. We have also a webpage dedicated to use cases to understand what other people can do, are doing with our data. This is very useful, and all the use cases are sorted by thematic or countries. So don't hesitate to have a look on that. You will find also tutorial videos and FAQ on the service. So that's all for me.
Thank you very much, Fabrice. I think quickly, I'd like to go on to the Q&A session. There were a couple of questions that were asked whilst you were presenting. So I'll just quickly read them out for you and maybe if you can address them. So there was a question on which kind of interpolation is applied to be able to obtain level 4 data.
Well, this is directly a very tricky question. I'm not the guy who write the scripts and use this kind of algorithm. Perhaps Hayley, you are muted, Hayley. Sorry.
Yes, sorry, but thanks, Fabrice. Yeah, I know I probably can say a bit actually about it. Before I worked at EUMETSAT doing stuff with level 1, level 2 data, I also worked in one of the places where they produce level 3 and level 4 data for the Marine Service. So I know a little bit about some of these processing flows. So I can say a little bit. It depends on which product you're looking at. There are certain types of different statistical interpolation you can do, but there's also a growing amount of sort of gap filling that's done based on statistics of longer term like climatologies. So I know this is the case with some of the ocean color products, for example, where they will fill the gaps based upon it's different types of statistical analysis for effectively looking at the types of frequency variability that occur most often, and you make the most educated guess you can to fill the gaps. If you're familiar with any of the, you might be familiar with some of the work done by some of the teams in Belgium on this. So there's a couple of pieces of software called DINIOF, DINK. These are different types of gap filling, and I know these are used in the service. So it depends precisely on the product, but yeah, there are these kind of statistical approaches where you look at the frequencies of variability, the gap fill. Hopefully that helps a little. I can send you more links to that if you're interested.
Okay, thank you very much, Hayley. That is much appreciated. I'll continue to urge anyone who has a question. Unfortunately, I'd have to apologize. We cannot allow all microphones at a time because of timing constraints, and also because there might be some distractions in case anybody unmuted during the presentation. I apologize for that. Please make sure you use the Q&A session to ask all the questions, and I'm pretty sure the team will be able to give you enough answers. We'll move on to the next presentations that are going to be on use case. So I think Hayley, you're not off the hook yet, and Fifi will be joining you to make the presentation on the use cases. So I don't know who's going to go first, whether yourself or Fifi. Fifi, are you there?
I think there were some slides from me first, but Fifi, do you want to start off and introduce the presentation, or up to you? I don't mind.
Oh, no, Hayley, you can go on. So
yeah, okay. Have you changed it? Like, just download the latest version. I can share a screen. Hang on. Second. Okay. Sorry, let me just find my screen sharing.
Oh, I can share the screen if you want.
Yeah, if you've already got it open, that'd be great.
Okay, just let's do it like this. Can you see the screen?
Yep, can. Great.
Okay, so go ahead. I'll just make it possible.
You want to introduce yourself first? Yeah.
Okay, okay. So I'm Fifi Adodo, and I work at Mercator as a market development and outreach officer, and I'm working also in Geo Blue Planet project initiative. I think I met some of you already in person and online, so stay tuned for the use cases.
Okay, so it's me again. You're going to be seeing me a few times over the next couple of days. But I'll say a little that it's nice to also be able to speak as well as about the satellite operations and the products, about the different applications they're used for. This is where I come from in terms of background. I actually worked on harmful algal bloom detection and carbon uptake and various different things in my previous job as a research scientist. So it's great to be able to see and share where our data is being used to actually make impact on the planet. So that's what this presentation is about. I'll present a few examples from our side, and Fifi will present some from the Marine Service, and you'll see that there's definitely some overlap. So it'll hopefully give you an idea of how you can use all the different products available under the Copernicus program for different applications. So thank you. Okay, next slide, please. Thank you. Okay, so as I said before about data from EUMETSAT, so we have the Copernicus satellites Sentinel-3 and 6. The data from these tends to suit these applications where you need rapid availability of the data. So if you need data within 3 hours, you've got to make decisions quite quickly. The data we provide from the satellites at level 1, level 2 is probably going to be quite useful for you. And similarly, the high spatial resolution, if you really want that. Some of the more blended products have to sacrifice this because they're bringing together sensors of different scales. So sometimes you lose a bit of that when you do these averaging processes and merging. But they have different strengths. So it's you're always kind of choosing and balancing what is the best thing for the different applications. I will say for Sentinel-3, one of the major benefits that it can offer in terms of helping applications is that it has these multiple sensors on board. So it has ocean color, sea surface temperature, and altimetry measurements. And so you can bring those 3 data sets together really nicely because the data is all being collected at the same time over the same locations from the same satellite. So it lends itself to these kind of synergistic applications very nicely. All of this, of course, feeds downstream into the Marine Service products. So you'll see that a lot of the applications that I mentioned here are actually more or less suitable depending on your particular needs for both product streams. A lot of our data is also used in scientific studies on remote sensing as a measurement methodology itself. So I'll talk a little bit about that too. Next slide, please, Fifi. Thank you. Okay, so yeah, talking about that. So level 1 and level 2 data, you'll see a lot of people who use it are using it in kind of scientific research context. So they're looking to see what can these measurements do, how do they work, how can we improve them? So it has a big role to play in research and advancing that kind of science and technology of remote sensing. But you'll also see that a lot of people do work into comparing data that we produce with in situ measurements or with models as well. So there's just a few examples here showing a wide range of different applications and phenomena in this scope. So you can see some validation there looking at ocean color data in the bottom left with in situ data around rivers. So you can monitor these things from boats, but you can also compare them to the satellites to see how representative that data is. You can use the data in combination to look at particular physical phenomena. So you can see the top left there, we can detect internal waves using both ocean color and altimetry data coincidentally together. In the middle at the top there, there's an example of a model validation comparing in situ, the model sea surface height field with sea surface height derived from an altimetry long track. That's the dots that you can see. In the bottom middle, there's another validation exercise here looking at comparing water quality measurements retrieved from drones and from in situ measurements with satellite data. Top middle right, I guess, you can see the picture of the coral there. This was a really interesting application where somebody was using the near real-time data to be able to correct imagery in the water. When you have an idea of what light is being absorbed in the water, you can then use that to say how much should I correct my underwater imagery for the effects of the water. So this was quite an interesting use. And then the bottom right is just another nice example of an interesting application from Leah Schamberger, who has been looking at using the data from Sentinel-3 to detect submerged sargassum. And this is a large algal species that causes pollution on beaches, in particular when it rafts up onto the shore. And it's a real problem for management in tourism hotspots. So quite interesting to know where this stuff is and where it's going to go. And this is how our satellite data can help towards that. Next slide, please, Fifi. So beyond those couple of examples there, I'd invite you to take a look at our case study library. You can see the link there. We try and produce lots and lots of these examples, both from things that we've seen, but also in collaboration with the wider community of users and scientists and various other people who are interested in our data to showcase what the data can do. You can find all these in the library. What we're trying to do more and more now is provide these with working examples so you can actually get hands-on with the data and do a little bit of analysis that aligns with these case studies that we're showing. And you'll see some of these in the coming days when we demonstrate how you can use things like Jupyter Notebooks and Python to access data. But I just wanted to show a couple of examples here. So next slide, please, Fifi. One of the things we've been doing recently is mapping some of our case studies to the UN Ocean Decade of Science Challenges. And we have released, I think, about 3 or 4 of these already, and we'll release more over the coming years. It's a whole decade, so we've got some time. We're hoping to produce more than just 10, but hopefully different ones that align with these different challenges. This first example, I know Fifi's going to mention it as well in a bit, looks at marine heat waves, and this actually uses both data from Sentinel-3 directly and from the Marine Service. And you can access their SLSTR data as well as the longer time series of sea surface temperature to identify things like marine heat waves, which have impacts on both fisheries and aquaculture, but also on marine ecosystems. Next slide, please. This is a particularly nice example from another one of our case studies showing the use of ocean color data to detect harmful algal blooms. And this work is actually done by another consortium from the GMES in Africa project. This is from the group led by South Africa and working up towards East Africa. And this was able to detect, this technique they've developed is able to detect particularly harmful species that are likely to lead to either toxic impacts on aquaculture or on, in terms of deoxygenation, where these big blooms die off. And then the water, they decompose, and this removes the oxygen from the water. And it causes these phenomena like you see the top right there, where you have die-offs.
Hayley?
Yes.
Can you speak a bit slowly? Some of our followers are struggling to follow.
Best.
So if you could,
yeah.
Yes, if you could just speak a bit slowly. Thank you.
I'll try my very best. I know I'm not very good at it. Sorry, I'll do my best. Yeah, so in this case, we can use the ocean color data to look at the plankton species and potentially detect a risk of what we call deoxygenation, which has impacts on these marine ecosystems and aquaculture and fisheries in this area. Next slide, please. This is another example where we were showing how the ocean plays a role in climate resilience. So this particular example shows how we can use ocean color data to contribute to the monitoring of ocean carbon uptake. Ocean color data, because it observes the plankton in the surface of the oceans, can give us information about the carbon they take up through the process of photosynthesis and calcification and things like that. So this example in this case study shows applying a simple calculation to ocean color data to estimate, in this case, you can see in the image, it's particulate organic carbon. But the wider case study also explores how this data can be used in other contexts to understand how much carbon our oceans are taking up. Next example, please. And then moving on to more sort of physical parts of what we can do with regards to satellite data. And this links nicely with EUMETSAT's kind of key role in weather and climate monitoring. We can use the altimetry data from the satellites to look at the impacts of extreme weather, in particular storms, typhoons, hurricanes, these big tropical cyclones. And you can see in this example, and if you go into the notebook, maybe later on during the week, you can see that you can combine this data from the along track altimetry with some of the merged products from the Marine Service, and also with other information provided by weather organizations to show how the sea surface height changes. So you can see storm surges, you can also see high wind speeds, and you can see big waves caused by these storms. And of course, this is important information that's used in weather forecasting, but also in understanding the impacts of these storms on coastal areas, what we need to do to protect them and maintain them in regards to things like future climate change and sea level rise. I think that might be my last one. Yes, so over to you, Fifi. Thank you.
Okay, thank you, Harry, for this interesting presentation. So yeah, in complement of what Harry have presented, I'm going to give some overview on the use cases from Copernicus Marine Services. As Fabrice already said, the Copernicus Marine Service provides free and open access to global observation products, in situ and satellites, and modeling data for the physical ocean, such as waves, sea level, currents, temperature, salinity, and so the biogeochemical ocean, such as nutrient, chlorophyll, plankton, ocean colors, to enable marine policy, support blue growth, and scientific innovations. So the Copernicus Marine Services offers a user-driven service designed to meet the three pillars of the UN Sustainable Development Goals, which are society, environment, and the sustainable economy. So as you can see here, the environment segment encompasses topics related to polar environment monitoring, climate and adaptations, ocean health, marine conservation, and biodiversity. So the society segments cover the science and innovations, policies and ocean governance and mitigation, education, public health and recreation, extreme hazard and safety. And the economic segment encompasses the marine food, coastal services, trade and marine navigation, natural resources, and energy. I'll now provide some example of how Copernicus Marine Services data and projects bring value through use cases in each segment. So in the environment, segments, I'll provide an example on the health sector. As shown on the left graphics, the Copernicus Marine Service provide inputs or variable to monitor the ocean states and vital health signs essential for the well-being of life on Earth. So these Copernicus Marine Services variables are used for monitoring coral health, as you can see here. So when water temperature is too warm, corals will expel the algae living in their tissue, causing the coral to turn completely white. So to monitor and track coral health, Microsoft Consortium use global ocean sea surfaces and sea ice products to provide the Copernicus Marine Service to develop a satellite-derived risk and monitor products for the ecological vulnerable coastal and nearshore ecosystem. The tool provides a user interface that offers an interactive map product viewer with click-up pixel information, giving users the capability to monitor the ocean thermal stress and durations, to identify bleaching alert area, allowing quick response to coral bleaching, and to track historical thermal stress events. So now, in the economic segments, the Copernicus Marine Service support the management of aquaculture farms and the sustainable exploitation of ocean living resources. The Copernicus Marine Service variables are used for supporting fish farmers' decision-making. As the sea temperature plays an important role in fish production due to the sea temperature effects on fish mortality rates and on fish growth, to sustainably manage fish production, Webstep, a Norwegian private company, has developed a predictive statistical model that allow predicting future temperature for a specific area using the Copernicus Marine Service data. These solutions allow users to save time and expertise for fish farmers to get a wiser decision-making and to support fish farmer decision-making with the impact future event might have in their business. In the society segments, I'll take the example of the extreme hazard and safety use cases. The Copernicus Marine Service supports safety at sea and pollution response by providing oceanic parameters for extreme situations at sea and pollutant drift focus. For example, Copernicus Marine Services variables are used for improving operation and emergency response at sea. Effective response to emergency at sea needs reliable ocean currents predictions. So to meet the needs of search and rescue operators, the IBSAR services has developed a free online tools that allow visualizing, comparing, and evaluating the performance of ocean currents prediction in the Iberia-Biscay Island regional seas. These tools allow users identify the most accurate ocean current prediction in a specific area and period of interest, which is crucial for organizing the most efficient emergency response. So these solutions helps to improve search and rescue and pollution control operations, to minimize response time, to optimize search and area planning, and to allocate resources effectively. Still in this the society segments, I will provide here an example in the an example how Copernicus Marine Services support businesses and no-profit organizations to develop public health, ocean literacy, and educational tools to raise awareness on the many challenges facing the oceans. So to better empower and inform citizens about our activity impact on the preservation of our marine environments, tools or services are built up awareness among general public, students, as well as local industry and political stakeholders. In this respect, we have the examples here, you can see, of educational support for broad public at Nausicaa Museum, which showcase exhibitions based on Copernicus Marine Service product to inspire people to discover and love the sea. There is also the project called the Children for Ocean, which propose awareness sessions worldwide focusing on acidifications, overfishing, and plastic pollution to inform as many children as possible in the hope that an educated child today will be an aware citizen tomorrow. So in conclusion to these presentations, these few examples of use cases show the importance and capabilities and reliabilities of EUMETSAT and Copernicus Marine Service data and products in understanding and addressing the challenges of our sector of the blue economy. So for more inspiration or use cases, please visit our site, EUMETSAT.int case study, and marine.copernicus.eu service use cases. So Hailey, if you have a concluding word, you can go ahead. Thank you.
No, I think that's fine. Thank you, Fifi.
Okay. Yeah. So thank you, everyone.
Thank you, Fifi and Hailey. There are a couple of questions that came up during your presentation, so I'll just quickly go through them. We have a few minutes to spare, so if we can try and address as many as we can in the time period. So the first question is on how can Copernicus be used to pinpoint marine pollution?
I can maybe have a bit of a go at answering that, then maybe Fifi and Fabrice also want to comment. So a couple of different ways, depending on what type of pollution it is you're trying to sense, and with the caveat that some of that would be better done by some of the sensors we've not spoken about today. So under the Copernicus program, you also get data from Sentinel-1 and Sentinel-2. This is available from the European Space Agency. Sentinel-1 is particularly good for detecting things like oil spills. It detects surface roughness, so oil changes that. So it's quite usable for that. You can also use Sentinel-2. It's quite high resolution optical. So if you're actually looking physically for like pictures of pollution patches, depending on what it is, again, you can potentially pick it up with that. The other thing I would say in terms of pollution that can be very useful, and maybe Fabrice wants to speak more about this, is the use of some of these merged data sets for looking at where ocean fronts occur or where ocean currents might lead to things conglomerating. This is something that's being used quite effectively, for example, to look at where debris is moving to or where plastic is accumulating. So that would be the recommendations I would give on that topic. But Fabrice, anything to add, Fifi? Maybe some examples from your case studies.
No, you're right. Yeah, the model data are very used in to to launch what we call drift simulation. So you can use the currents to know where the debris are going, and to use also the model in backward mode in order to be able to find the source of the pollution also. This is the case for oil spill, for example. You can use the model in forward mode to know where the oil spill is going to reach the coast, and in backward mode in order to find the boat who is responsible of this pollution.
Yeah, I think everything is already said. So it depends on also which pollution are you looking at. Even there is ocean color that can help also for detecting surface pollution as sargassum, also a plastic, marine plastic. But for the drift modeling, you can use surface currents to see where these plastic mats are driven to, even for the rescue also, to see where debris can move on. So I think, yeah, there is many variables you can use depending on the topic of your subjects.
Okay, thank you guys. The next question is on, sorry, can you hear me?
Yeah.
Yep.
The next question is on the coverage of the Copernicus and Sentinel data sets. So there are two questions here, which I'm going to merge into one. There's one asking about its availability in the Red Sea, and there's another one also in the Gulf of Guinea. And also, if you could add on to it, the temporal and spatial resolution of the data sets.
Maybe I can talk about the satellite coverage first. I mean, generally speaking, most of the satellites cover pretty much the entire globe, but certainly Sentinel-3 and 6 do, with the exception for some of them of the very high points in the Arctic and Antarctic. But there's coverage from Sentinel-3 certainly for the entire globe, and Sentinel-6 as well. So for these cases, yes, you'll find that. The marine service products, maybe Fabrice and Fifi can speak to. But yeah, from a satellite perspective, at least for Sentinel-3 and 6, you'll get coverage from all of the mission products from us.
Yes, it is the same for the products from the Copernicus Marine Service. We cover the global ocean.
Yeah, I think there was one. Ignatius, were you also referring to the one on the spatial resolution?
Yes.
Yeah. So I can.
Yeah, especially.
No, because they're not the same for all data sets.
Yeah, spatial resolution is are completely different. That's why we always in general said that you can find complementary information from satellite data or model data, because on satellite data you will have high resolution images or information on the coast, on the ocean, etc. But you need to wait some days to have a complete cover of the ocean. This is not the case for the model, but the model will be with a low resolution than the satellite information.
Okay, so there was a specific question which had to do with altimetry data over the Gulf of Guinea, and then the spatial resolution, and then does it come in near real time, or what is the temporal resolution then?
Yeah, it does. I mean, so from us, it comes within 3 hours, all the altimetry data. It's a long track data, so I think it's a bit less for Sentinel-6, but for Sentinel-3, it's like 300 meters a long track. For Sentinel-6, you can do more to get closer, but for the long track, that's that. But there's level 3 and level 4 altimetry products from the Marine Service. I'm not sure exactly how quickly they're available. I guess on a daily basis. Fabrice, do you know for the altimetry 3, 4? Check and find out for you.
Yeah, I can check.
Because they've got to combine all the data from all the different altimeters together, so you don't get it quite as quickly as from the individual satellites, of course. You know, we have to give them some time to do the work. They can do a good job, but maybe not quite that quickly.
Okay.
Oh,
It seems
well,
also that there are a couple of questions from the angle of meteorology, because I'm seeing questions on data sets such as, is it possible to use this platform to track some scientific happenings like lightning and thunderstorms and the amount of infrared radiation reaching us?
In part, yes, but that's very much more, I would say, my EUMETSAT hat. So if you'd like to know more about those products, I can give you lots and lots of information on those. Maybe offline we can pick it up. But yeah, certainly on new missions, we'll be doing more with lightning. IR, some of our, we have a system called the Satellite Application Facility. So a set of organizations that support downstream use of our weather products. They produce IR products that are relevant. It's particularly safe if you're wanting to use them for looking at like solar power and stuff like that. So yeah, there is within not particularly Sentinel-3 and 6, but the wider satellite data ecosystem, there's information on these products available, so we can give you more on that. Start with our website, and if not, email our help desk and we can put together the portfolio for you.
Okay, and the last couple of questions, it says, how are these remote sensing data sets from the ocean calibrated? And then to join in with the last question, he also says, are these data sets validated, or do you need to validate them with in-situ products?
I can maybe say a bit about calibration. So yeah, this is something we have to do at EUMETSAT, is to make sure the satellites are calibrated, and there's various ways we can do this. We can look at how they're performing over specific targets that are particularly well known and calibrated. This is very well characterized, sorry. So like you can look at like desert sites, for example, and you can see how the instrument is performing over those particular locations. It depends on the instrument, of course. We also then compare to well characterized in situ instrumentation. So we have buoys that measure the light leaving the water, which we compare for the ocean color. We have buoys that are measuring the sea surface temperature, which we can compare. We can compare for the altimetry to tide gauges and things like that on land as well. So there's various different ways we can calibrate the satellites. Calibration, validation, there are a little bit of crossover there, but the calibration is where we take what we've seen in situ and then we correct the satellite for it. For validation, we do validation as well. So we compare to an independent series of measurements, as I know do the Marine Service for their products. But I would always recommend you to check if you can yourself, because we can't get everywhere with our measurements. In situ data is like gold. So especially if you're working in coastal waters that are particularly weird or in particularly extreme situations, it's always good to check if you can. But we do provide the information. I think Fabrice mentioned they have quality reports as well, so I assume that includes validation, Fabrice?
Yes, and for all the products, you will find information about how we validate the product, and we have also a part of the website dedicated for product quality dashboard. So you can have information about the different kind of products, and mainly the model product, and comparison with satellite observations and in situ observations. So it gives you a good idea of the quality of the products you will use. So I can share the link of this in the chat.
Okay, thank you guys. The last set of questions I think will be answered in the next session. So I'm not going to go too much on it because Haley and the guys are going to talk much on this. So we move on quickly to the next part, which is going to be on the WEkEO Data Information Access Service. We're going to get a general overview of it and then the catalog of products. So you are now going to be able to find a full list of variables and how you can use them. So I'll leave that set of questions to Haley and then probably Fabrice to address in the next part of the sessions. So Haley, I'm guessing that's going to be you for WEkEO.
No, I think it's Fabrice for this one.
No.
Doing the demo, isn't it?
Yes. The general overview and the catalog of products are for me. This is my day.
Okay.
Tomorrow it's the Haley day.
For me tomorrow. I'll show you around tomorrow.
All right. Thanks, Haley. Okay, Fabrice then.
But stay with me, Haley, because I will talk again about Sentinel missions and all this atmospheric information. So can you see my screen again? Yeah. Okay, let's move on this presentation. So this is an overview of the WEkEO DAS service. So WEkEO is a data and information access service. So what you can find on WEkEO and what this is the goal of WEkEO. So WEkEO is a portal to give access to all the Copernicus data and products available, and also to give access to virtual processing environments and user support to allow people to play with the data, compute the data, near the data. So you don't have to download all the catalog of data to make your own computation on your own computer. You can make this on the resources, the computational resources available on WEkEO. This is very important to know that. And to make a clearly difference with the Copernicus Marine Services or EUMETSAT, WEkEO can be very useful if you have to take a challenge who need you to access different kind of data from the marine side, from the land side, the atmosphere, the climate, or the Sentinel missions. So you have the different catalog of the different Copernicus services and the Sentinel missions available, and the computational resources. So you can play with the data on the computational resources. So this is not only a catalog of catalogs. Okay, this is more than that. And again, we try to support the activity and the different European projects, the private sectors, the academic sectors, and the civil society. So as I said, behind this WEkEO, you will find the institutions already in charge of the different of some of the Copernicus services, like Mercator Ocean for the marine monitoring. Mercator Ocean is also in the WEkEO structure in charge of the user development and management. SMWF, who is leading the climate change monitoring service and the atmosphere monitoring service, is responsible for the tools, development of tools, and EUMETSAT, who is in charge of the upstream satellite data on the infrastructure of WEkEO. And the European Environment Agency, who is leading the land monitoring, joined the WEkEO team and start to provide its information through this platform. So, as I said, you will find the Copernicus data plus virtual environment tools plus very strong user support. And we put a lot of effort on the Copernicus data to harmonize the data, developing API called Harmonized Data Access. And because sometimes atmosphere data, climate data, marine data didn't have the same format, the same metadata, the same information, etc. So we try to harmonize all of this through this piece of code, allows you to access the data, and you don't have to focus on which data you're going to download. It's already done by this piece of code, this API available on WEkEO. So we try to facilitate the access of all the data for users. Then you have this cloud infrastructure with a certain capacity of storage of computational resources. So this is the single access point. So this is a platform. This is the website. So you will find information about the event we can organize, the news about the improvement of the service and the different catalogs. You can find documentation on how to use the services and the data part, which is the catalog of the WEkEO platform, available through a viewer. So you have just to browse the catalog of data, select the data you want. You can directly download, or you can directly play with the data on the computational resources. To do that, you have just to be registered. This is not the same credentials that you can have on the Copernicus Marine Service on the EUMETSAT platform, but we are working to harmonize this authentication and to allow people to have a single login and password for all the Copernicus service platform. This is the future for the users to be able to navigate on all the platform with only one credential. So as I said, in terms of portfolio, you will have access to the different portfolio from the Copernicus services. I will give you an overview after this presentation about all the data available and the Sentinel and contributing missions. So Sentinel 1, 2, 3, 5P, and 6. So this is a reminder about all this. So data catalog, computational resources, 3 trials. You will see that we have, I can move to the next slide. I will come back to this. Okay, we have 2 plans to access the computational resources. We have the free cloud computing. This is the first level. Okay, you have just to register, and you can download the Copernicus and Sentinel data using the data browser or via the harmonized data access API. You have access also to a Jupyter Lab. You can start to play with data with some Jupyter notebooks, and tomorrow you will see that with Ailey and Ben, how to start to play with the Jupyter Lab of WEkEO. A library of Jupyter notebooks are already available with some use cases very interesting to play with atmosphere data, marine data. We have on the WEkEO website also a Jupyter notebook gallery. And you can store your code and results in a WEkEO drive. This is a free plan. If you need more computational resources, you can have access to this also, but this is a pay plan. And you can choose the size of the computing resources you need, and as you can see, this is the offer. So there is different prices accessible on the website directly. So you can see there is different what we call t-shirt size offer, and if you need more virtual machine, more storage, object storage, etc., you can find the offer you need. And for some of them, you have trial period. So during X months, you can use for free this offer in order to test if it's the correct size for your job, for your activity. So I came back to this slide as a reminder, the 3 main assets from WEkEO. The data are is not a copy, because there is other existing DIAS platform from the private sectors available, but they have to copy the data on their cloud, and then they give you access to their cloud. The problem is sometimes when you copy the data, you can have problem in copying the data. Simply, you have not access to all the data. You can have delay, but on WEkEO, this is not the case, because we have all our infrastructure to store the data and to give access to the data, and we have just linked all these infrastructures together. So it's very innovative way to make this accessible. We have a harmonized data access. As I said, We have a single protocol to access to all the different data sources from virtual station or Jupyter Notebook. So it's very, very, very useful. And expert user support, because the user support is directly linked with the producers of the data, which is very important. This is not the case, for example, for a private company who is giving access to marine data on its own cloud. You will not find expert information on this kind of structure. Okay, this is the cloud resources. So this is just a reminder. So for free, you can have access to the web portal. You can start to discover the data through the viewer. You will have this demo of the viewer on the website tomorrow with Ailey. You have just to register. This is free. Thanks to that, you will be able to download the data, to train on your account. You will have access to the Jupyter Lab to start computation. If you need more resources, you have to pay. Okay, the Jupyter Lab, it's very, very useful for people to discover the data, to start to play with piece of Python codes. We have already a Jupyter Notebook gallery accessible with a lot of Jupyter Notebooks already validated. So they are working on the Jupyter Lab of WEkEO. Again, you have just to be registered, click on the Jupyter Notebook you want to test, and you will directly be able to launch and to run the Jupyter Notebook on the WEkEO platform. This is very useful for people who need to discover how to play with the data, how to understand what's behind the products. We started this year a series of training workshops. So WEkEO for universities, this is a training, and we have this training the 14, 15, and 8th of March, so 14, 15 of February. So this is same days, today and tomorrow, but this is the morning. So if you are not already registered, you can register if you want more information about the specificity of WEkEO for universities. It can be very interesting. And then we have a series of different thematic workshops on WEkEO during this year. So this is at the end of this first presentation about the WEkEO. Let's continue with the last presentation about the catalog of data available on WEkEO. Let me share my screen again. Okay, let's continue. So with the product offer on WEkEO. So as I presented before, you will access on WEkEO on the different Copernicus services portfolio with the land monitoring service, Copernicus Marine Service, atmosphere monitoring service, emergency monitoring service, and climate change service. You will find different kind of data, in situ, satellite model, but also charts and maps, and also information and products from the Sentinel and contributing missions. So I'm not a specialist of all the services and all the kind of data, so I will just go through the different services to give you just an overview. This is, as I said before, this can be very interesting for people who are working on activity who needs different data from different sources on the marine world, the land world or the atmosphere world. It's the case for people who are working on coastal activities. So you will find marine data, land data, and you can play with these two kind of products on this platform. That's why we found interesting to introduce this WEkEO service. So the Copernicus Marine Service are already made this presentation, so I will go very quick on that. So different kind of data sources, in situ data, satellite data, and model data. And you will see for the atmospheric atmosphere monitoring service and the climate monitoring service, this is the same kind of products you will find in situ satellite model. So satellite observation, in situ observation, and model data with blue, white, and green parameters. Okay. From the climate change service. So you will find in situ observations, which are typically made at weather stations or using weather balloons at many locations around the world. You have a long time series of in situ variables, and variables can be on glacier elevation, distribution, graded temperature, and precipitation. You will have also satellite products with indirect measurement that are transformed to weather data using algorithms. And in terms of variables, we will have information on different gases, CO2, radiation, sea level, sea ice, water vapor, and humidity. And about the models, you can have a different kind of model products from reanalysis model, from climate model forecasts and climate model projections, and the projections are made on many decades or even centuries into the future. So about the reanalysis data you can find on WEkEO, this is reanalysis data from ERA 5 on the global scale. Urea is focused on Europe. The climate model forecasts are also provided in the form of seasonal forecasts. You have also climate change projections, which can inform on climate over the next couples of decades and century. And sectoral impact data is produced from sectoral model relevant for water, agriculture, energy, and insurance. So don't hesitate to have a look on the catalog of the climate change service directly on WEkEO. And again, you can ask your question to the WEkEO user support. Quick overview about the atmosphere monitoring service portfolio accessible on WEkEO. As the climate change monitoring service and the Copernicus Marine Service, you can access in situ, satellite, and model products. So the Copernicus Atmosphere Monitoring Service combines information from this observation to compute models of the atmosphere to generate an accurate estimate of atmospheric variables, such as temperature, ozone concentrations, and amount of aerosol particles. So as you can see, you have different instruments providing information with weather stations, commercial and research aircrafts, balloon sounds, and from satellites, different family of satellites. And for the models, You have different line of production systems with global and regional supplementary and emissions model. And as you can see, you can find information about greenhouse gases with analysis and forecast global model, air quality on regional European region. On the global, you can have more information about greenhouse gas fluxes, climate forcing, and global fire emissions and anthropogenic and natural emissions at the global scale. About the emergency monitoring service, they are so the Copernicus Emergency Service monitors Europe to forecast, analyze, and provide information for resilience strategies. It has two components on-demand mapping and early warning and monitoring. What is currently offered on WEkEO is yearly warning monitoring. Okay. And on that, you will have information on the geospatial information at European and also global level through continuous monitoring and forecasts for floods, droughts, and forest fires through the following system: the European and Global Flood Awareness System, called EFAS or GLOFAS, and the European Forest Fire Information System. From the Land Monitoring Service, the Land Monitoring Service provides geographical information on land cover and its changes, land use, vegetation, state, water cycle, and earth surface energy variables to a broad range of users in Europe and across the world. Again, you have global coverage with this service. So the main components of this service are systematic biophysical monitoring, land cover and land use mapping, thematic hotspots mapping, and reference data. And if we dive by different category of products, about the vegetation state product, you will have information about the vegetation properties, with the fraction of absorbed photosynthetically active radiation, the vegetation indices, the dry matter productivity, the burnt area, the map of burnt areas delineate the zones of globe affected by fire events. You have the energy budget product with information about the land surface temperature, surface albedo, the top of canopy reflectance, water information about the lake surface water temperature, the lake water quality, the different water bodies and water level. And next slide, about the cryosphere products. You will have information about the lake ice extent, snow cover, snow water, about the hotspots, and more dedicated to specific topic like Urban Atlas, Natura 2000 zones, areas, and coastal zones, about the different land cover on this zone, and the ground-based product with high resolution layers, biophysical parameters, and land cover data. I give you just an overview because I'm not a specialist of all this Copernicus portfolio, but I think it's interesting for you to know it exists, and you can have more information on the WEkEO website. A quick view on the Sentinel and Sentinel mission. And I will not dive into details with Ailey on board. I don't want to say a mistake. So you have information from Sentinel-1 with mainly radar information, and the Sentinel-1 data products distributed by WEkEO are level 1 products. And then Sentinel-2 data, the products. So Sentinel-2 instrument is a multispectral imaging instrument, and you will find products in WEkEO on the different reflectance, top of atmosphere reflectance and bottom of atmosphere reflectance. Sentinel-3, so this is the blue Sentinel with 3 main instruments, an altimeter called SRAL, an imaging spectrometer dedicated to ocean and land color, ALSHI, and a radiometer to measure sea and land surface temperature radiometer, so SLSTR. So ALSHI with level 1 and level 2 on land and ocean, and the sea and land surface temperature level 1 and level 2. Sentinel-6 mission with the altimeter Poseidon, so information on altimetry with level 1 and level 2, and the microwave radiometer for climate instruments. So you have access to all this this information on WEkEO. So that's all for me.
Thank you very much, Fabrice.
It was a quick view on a quick overview of the catalog of data, but this is very interesting, and I'm pretty sure that people will be interested to find more detail on the website. And again, don't hesitate to contact the WEkEO user support for more information.
Okay. Thank you very much, Fabrice. We're almost out of time, so unfortunately I cannot take too many questions after just now. I'll just take a single question or two, and then most of the questions here are actually related to activities that will be handled tomorrow. So from tomorrow, all the sessions will be more or less demo sessions where you'd have a hands-on session with Haley and Fabrice demonstrating the various platforms to access and actually do some analysis on these data sets. So I won't be tackling those questions today. So there's a question here. Does the data set contain information specifically about the impact of aquatic weeds on the phenology of phytoplankton and zooplankton in freshwater environments? You're muted, Fabrice.
I'm really not sure of that, because when we talk about freshwater environments, I think about more satellite information or land Copernicus land monitoring service information, and I'm not aware about that in details.
No, I guess I can say that you can certainly use, I know that Sentinel-2 can be used to detect certain types of aquatic weeds, particularly like things like water hyacinths. I've seen it done with, obviously we've seen it done with sargassum. Sentinel-3 can do that as well, but not explicit. I don't think there's any metrics that show the impact then of this on other blooms. It's actually, it would be very difficult if you've got an area that's very full of weeds to then tell what else is going on with the plankton, because that would be the major signal the satellite sees. But you know, if you wanted to look at the weeds and then blooms that might happen afterwards or stuff, you could probably do that with some of the time series available. Would need a bit of custom processing, I think.
Okay, the next question. Is there any link to download data to compute LSD and any guide to follow using SNAP or ENVI?
I know you can get the LST data from ESA, so you can get from SLSTR, this is land surface temperature, assumedly, which means it's also then available through WEkEO. You can download it there. I don't know if there's any guides to follow it. I can have a look and see. There might be some online. SNAP may have provided some themselves. It's not something we do. We provide the SST equivalent, but not the land. But I can have a look for you and see what I can find.
Then, does the data set contain data on water depth?
Yeah, there was also a question about bathymetry here, so these might be related. Not explicitly would be my answer for this. So bathymetry estimation is an application that people have been exploring using Sentinel-2 data for quite some time, but it very much depends on what's in the water at the time you're trying to define and determine the bathymetry. If the water is full of sediments, it's very murky, you can't see the bottom, the satellite's not going to be able to tell what the bathymetry looks like. If the water is pretty clear, then you've got a decent chance of it. This is not a product that's provided generally, but there is a tool in SNAP called Sen2 Coral that you can use, which will provide an estimate of bathymetry, and as well as some other things. It's a really interesting piece of software. You'd have to try it and see how well it works for your region. There's some really interesting work being done on this kind of thing, but it is still quite cutting edge research, to be honest.
Okay,
yeah, you can find information.
Okay, sorry.
Sorry,
no, go ahead,
yeah.
Sorry.
No, you can find information on about bathymetry on different international collaboration like GEPCO,
Yeah,
if you need
a big scale
high resolution bathymetry.
Yeah.
And our last question for today: which data format is less heavy for the computer memory when downloading large time series data?
I can say a little bit about this. I don't know if you mean format or if you mean services here. So, I mean, the reality is you're going to need to try and subset your data as much as you can in order to limit what you're downloading. Things like WEkEO, the HDA will allow you to do this. I mean, the benefit of WEkEO is if you're using the resources, the hosted processing, you don't actually have to download to your own machine. You can just download to there. So the storage is determined by us and not by you. So that's one reason we're presenting that a bit more. There is other facility that allows you to do that. The Open Data service at CMEMS office, for example, allows you to subset. You can download by product content partly at the moment from EUMETSAT and partly until you'll be able to use the data tailor to do a bit more of this. But yeah, it's not easy. You just have to kind of customize your workflow as much as you can, and yeah, maybe look at cloud as a real option if your data set is actually that large. Yeah, so it's a challenging one.
Yeah, FTP for me is not a good solution.
Yeah, if I away from that now.
Yeah.
If I can jump in, also you can say that you can rely, if you don't want to download more data on your own computer, you can use the WEkEO solutions. Just having your own credential and account, and you can just process the data directly on this server. So that's one issue solution also to this kind of infrastructure or maybe memory issue you are facing downloading high format data, and so yeah, just rely on WEkEO and go ahead.
You will have more information tomorrow during the live demo to show how to subset as maximum as possible the data to be sure that not to download the gigabytes of data, but just the area and the depth you need.
Okay, thank you very much, everyone. It's the same link for tomorrow. For tomorrow's sessions, we're going to be looking at mainly the demo sessions for WEkEO and my Ocean Pro viewer. So it's going to be a very interactive hands-on gym. We'll be looking forward to that. The recordings will be made available for you once the meeting is completed. And before we go, I'd just like everyone to turn on their web cameras so we can get a group photo of everyone in here.
I'll also remind everybody to register for WEkEO. If you haven't already, please do.
Yes.
Then you can start playing with it while we're talking and you can ask more questions.
Yes, I think Haley has already put the link in the chat section. So please visit the link on WEkEO, register, and then it will be far easier to work on it tomorrow. A few seconds more if you want to get into the picture frame. The time is now. Turn on your cameras.
Cool. It's so cool to see you.
Okay, I see a few more people are still coming.
Come on, don't be shy. Open your camera.
Oh, there are lots of people there. Okay, thank you so much. It's exactly 4 p.m. I'd like to thank our presenters, Fabrice from WEkEO Ocean International, Haley from EUMETSAT, and Fifi Adodo also from WEkEO Ocean International. It's been lovely having you. Join us tomorrow. Use the same link, and we'll have a great session as well for tomorrow. Thank you very much for joining the session today.
Thank you, Ignatius.
Great hosting, Ignatius, and thanks everybody for the great questions. See you tomorrow.
Thank you. Bye.
Bye-bye.